Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
I never said that I was the smartest person on earth. You people did.
I just want to make a quick update regarding recent development in the cybersecurity. So there was Backdoor that was discovered in XZ library, which is related to compression. And that library is also used in the liblzma, and eventually it gets loaded into SSH, which means all of this backdoor and all the vulnerabilities kind of directly ties into SSH. And as you might already know, SSH is the way usually system administrators access the Linux operating system, right? Linux, Unix, FreeBSD, doesn't matter. So in this short video, I just want to very quickly go over a couple of important points. We are going to cover how it all started, a quick technical details of the backdoor, and are there other backdoors? Like this is discovered, yes, but are there other ones? Attribution, and the final takeaways. Okay, the first part is actually how it all started. First of all, how it all started, like how we all got to know about it. It all started by a Microsoft security researcher. Actually, I don't really know his job title, so he is the person that you see on the screen, Andres Friund. He actually was doing some performance benchmarks and things of that sort, and noticed that there are a lot of wall grind error messages and crashes and performance issues. Like it takes long time for him to log into SSH, so he started the analysis. Eventually he discovered the backdoor in XZ, which eventually gets loaded into SSH, and he makes a post on the OSS security, open source software security, on openwall.com, and then all hell breaks loose, right? So the timeline is actually kind of something like this. So a person calling themselves Gia Tan with that with a username of Gia T75, an email address of Gia T0218 at Gmail, starts fuzzing various projects, right, including XZ. And he or she makes a pull request in OSS fuzz, which is related to these fuzzing things, right? Open source security software fuzzing. And then Gia, on February 15th, 2024, adds a git ignore rule to XZ repo. Initially, it doesn't mean anything. It does nothing. But then on February 23rd, Gia adds the part of the backdoor. So it's a part of the backdoor. It is actually two sample files, test files that are used to. There are test units, test files on almost all libraries, right? That they want to make sure that when the library is compiled or the code is compiled, it's actually doing what it's supposed to do. So there, the Gia adds two files. One is a bad-3 corrupt LZMA2. One is a good large compressed LZMA. And on its own, these two LZMA test files, as is, are harmless, right? Because you need to basically load the decoder, the obfuscation, and all that stuff. So on February 24th, finally, one day, he just waits one day, or she, and then it submits the final stage to build-2-host M4 file, which is the last piece of the puzzle. And it basically extracts, deobfuscate, drop the backdoor SO file, and basically compromise the final build of the XZ library. The last week of February, after this commit, right, there are various reports of crashes and wall grind errors and stuff like that in various different issues created on GitHub and other sites. So this Gia hears about it and it starts working on it. But as he's working to fix this, 3 days later, backdoor XZ utils 5.6.0 is pulled and compiled and pushed into Fedora library, the crashy buggy version, right? And the backdoor is released basically on the March 9 on the Tukani project GitHub page. March 4th, Gia tries 3 times, 3 different commits. So there's like, I think March 4th is March 5th and March 9th. There's like 3 commits, and he tries to fix these crashes. He kind of manages, but not really. He manages to fix those issues and crashes, and there are like 3 more logs of his commits and his fixes on GitHub. And then 20 days later, so March 29th is the day basically Andreas makes the post on OpenWall OSS mailing list. So the whole thing kind of lasts like, if you count February 24th, he commits the malware, the backdoor, until it gets detected. You can give or take like 1 month. That backdoor code is in that XZ library, a little bit more maybe. Based on this table that I stole off of some blog.
For the first time in my life, I feel like I've stolen enough.
These are the operating systems that are, again, remember, this cutting edge, right? If you're using an Ubuntu or a Debian that, as soon as somebody makes a commit, the next day it's not released to you, so you can install it with apt install. So if you're not on that cutting edge testing and unstable and experimental and development versions of these operating systems, yes, you might have received that vulnerable backdoor code into your system, which makes your SSH server vulnerable. So that's going to be these Linuxes that you see on the screen: the Fedora, Debian, Alpine, Kali, OpenSUSE, and Arch Linux, right? So it depends. Check if you're using any of these. Again, the cutting edge version, the testing unstable whatever version, right? So quick technical analysis. Let's see how does it all work. It is actually very smart. It all starts during the build phase, but if I want to build the XZ and I want to run the XZ, I'm not gonna see it at all. I'm not gonna see the backdoor injected into the XZ library that I just built. Why? There are so many checks, and this is smart. See, so first of all, it checks if it is a x86, x64 build, right? So if you're again building for SBCs or some other non-x64 variant, it's not even gonna work. Okay, so that's the first step. Then it just makes sure that you are using the GCC. Not really sure what they were trying to do in there. Like, I think that's the only way you can build it. If you know the answer, please let me know. I don't understand that part. Like, why necessarily just check to make sure that you are building with GCC and not some other compiler? Yeah, I didn't get this part, honestly. If you know, please leave it in the comment section. I really want to know. But then this part is the important part. The injection of the malicious code only happens when you're actually building the Debian deb file or RPM for the CentOS or other operating systems, that the Fedora and others that use that RPM packaging, right? So if you're just compiling the XZ, you're not going to see it. If you build the package, if you are building the deb or RPM, then and only then it inserts and injects that backdoor code into your library. So that's why it probably slipped in many cases, because if you're a developer, you're not going to compile a deb and RPM every single time you compile something and want to try and test it, right? You compile it, you run it, you do benchmarks, everything looks good, no wall grind crashes because it's not there, backdoor is not there. But once you feel comfortable with your code, that is when you actually build the deb and RPM, and that is when you're building that, it injects the malicious code into your library. After the obfuscation of the first stage, we end up with this. Again, I stole it off of Twitter, so as you can see, that's the source. So this is actually a very novel way to ship a backdoor in an open source project, right? So they wanted to put a whole backdoor in the code. Obviously, if you put a huge blob in a code, everyone's gonna be suspicious, especially if you don't have any history with the project or like very little history. Suddenly you're coming to this project and you're committing such a huge blob of unobfuscated encrypted string. Everyone's gonna, it's gonna raise eyebrows. So what these guys did was, they're smart, right? So what they did was they actually encrypted, obfuscated, and implanted this into test files. And test files for XZ is going to be compressed and big, large blobs of files. So you just want to see if XZ can compress this in an acceptable time, and if it can decompress it, or if it can detect the crashes and errors in the bad formatted, malformatted the XZ file. So That's it's going to be chunks of blobs of binary. If you obfuscate and inject and insert that in there, I don't think it's easy to detect, right? It's not easy to detect that part where you are actually deobfuscating and decrypting. If you kind of hide that part a little bit well, like how these guys did, you're gonna get away with it. So that's how it all started, right? And most of the backdoor code, the hook part, we're gonna talk about it. All those are in the hidden in the two XZ test files. So these are the ones that you see on the screen: test/file/battery corrupt. And if you're a security researcher, I'm sure you can find it. But if you want to get your hands on these samples, let me know. I will share. How it all works is basically once the liblzma is infected, it gets loaded into OpenSSH, because OpenSSH server, the SSH server, relies on liblzma, and it's one of its dependencies. It does have a lot of dependencies. Each one of them happens to be LZMA, and one of them is OpenSSL. It's going to come up later. The infected liblzma, as soon as it is loaded, it attaches itself to the as soon as it is loaded in SSHD process by SSHD process itself, it hooks the RSA public decrypt function, right? And as you can see on the screen, this is a function in OpenSSL, and its job is to kind of validate if you can encrypt or decrypt some data, right? And that's the signature verification part. And the backdoor checks if the RSA public key, the N, the modulus, which is the fourth argument of the RSA public decrypt function, and it checks if the malicious code attempts to attempts to decrypt it, and then it uses an hard-coded cha-cha-20 key, right? And it checks if the decrypted N modulus data blob thing, it adds up to correct, well-formatted data after decrypting it with a stream cipher, which is cha-cha-20, right? If it is not well formatted, right? If you have a blob of text, it's not coming from you, right? It's not encrypted with cha-cha-20, the key that you have, and it's gonna fail the check. So if it is not coming from the attacker, the library detects that with the ED448 elliptic curve algorithm and cha-cha-20. Fancy stuff, right? Very fancy stuff. Like, I don't know, they could have gone with, I guess, RC4 stream cipher and some the RSA function to validate the key, or hash like MD5. I don't know, like these fancy things. It's a little bit telling. Again, you can't say it's not, anyone can maybe decide to do this, but this level of sophistication and attention to detail kind of shows you, it suggests, but it might be nothing at all. Actually, there's a proof of concept code on the GitHub, which if you run it, it will come all the way to that function. It will trigger it to that function. But obviously, because we don't have that elliptic curve key or the cha-cha key, and we have the key, but yeah, we can't really mimic the attacker unless we break that ED448 key. It is to basically prevent anyone else from abusing this backdoor, right? So they put it in there for that purpose. So it's not really easy to mimic that. So if you want to really abuse this backdoor or play around with it, as is, it's going to be a little bit challenging. But if you alter the binary, change the key, change the verification, change the cha-cha, the hard-coded key or something like that, you might be able to get away with it, and actually then you will be able to use the library as is and get access blindly to some SSH server. This is what happens if those checks and validations pass, right? The cha-cha and then ED448, if these pass and it makes sense after all that and the signature matches, the system then will execute whatever is coming as a payload by passing it to the system function. And the system function, right? So it just, whatever you pass to the system function, it basically executes in the system. And if it is not valid, then it passes everything as is, the original state, to the real RSA public decrypt function. So you can do that. I think that's where they went wrong a little bit, and that's how they, some of the packages was not getting properly handled and causing some wall grind issues, memory issues, something like that. Glad they couldn't do it properly when they got caught, but it could have been much worse, but we'll talk about it. Other backdoors? Question. So this guy, the Jia10, I don't think that's anyone's real name, but contributed to libarchive as well. So it's XZ is not the only one he committed to. And honestly, I would scrutinize every single thing this dude did, right? Or the gal, I don't know. So whatever these people done, it should be scrutinized. If he touched any library, any open source library, it should be scrutinized and checked. Which people are already doing, the experts are on it, and the people who maintain the repo. So one of them is actually the libarchive, right? So the February 6, 2022, he adds some validation to LZMA and LZMA2 encoders. Improving. I mean, come on, look at the code. I get it. It's helping, I guess. You see that he or she, doesn't matter, checking for the options argument, which is the first argument passed to that function, and it's checking if it is null or not. If it is null, just exit right away. So return. So I guess this is helping, but yeah, like attempting to fix things, right? Showing the goodwill, like I'm a good guy, I'm fixing stuff, if it is fixing at all. And there is actually one of the commits that he made is with the message saying added error text to warning when untarring with BSD-tar, right? And in doing so, he basically replaced the fprintf function which was the safe one. The original one was safe one. So original one was safe underline fprintf, and he replaced that with the regular fprintf. And as you can see on the screen, someone, Mike Siegel, on GitHub actually republished some code. As you can see on the video that's playing over there, it's actually his video. So as he's showing here, he's able to kind of abuse that, escaping fprintf, a safe and non-safe version, and he's kind of getting not necessarily code execution, but he's showing you what he's doing there. You see, he's writing an echo, all your base belongs to us, and with the edited version that gets executed. So as I said, he also might have added something to libarchive. So it's getting checked as we speak, and maybe committed other stuff. I don't know. GitHub closed the guy's account, or banned or disabled or whatever. And right now, whatever you can see is all from archive if it is available. So we'll know more soon, I guess, from Microsoft and Google as well. So we'll know. Impossible, right? Attribution. I don't know. I don't think it is possibility, but obviously, such sophisticated attacker, the idea, right? We're gonna create an account, we're gonna go after XZ, and XZ gets in the lib LZMA, LZMA gets into SSH, we put it in, we hook this function, we do this, you see? The idea, generating this idea, crafting this, and saying, we're gonna put the backdoor in the bad and the good test files, it's gonna be binary, and then we're gonna do this, we're gonna hide the final stage of the payload where we decrypt those hidden obfuscated stuff. When people are building deb and RPM packages, only then we do that. And then using ED448 curve and Cha-Cha 2020 and Cha-Cha 20 and all these things, kinda, again, nothing is definitive, right? If it turns out to be a single dude at the end of the day, I don't know, I guess, but I think it is the sophistication points to a nation state, attacker. The Chinese New Year celebrations usually starts like February 10th. I know it because all my packages was getting delayed, that stuff that I was buying. It ends around February 24th, and the backdoor was added February 24th. Coincidence? I don't know. I have no clue. The name Jia does have Chinese origin. Does this all mean anything? Nobody knows. I can create and use some, Slavic name. I can use some German name and pretend to be a German. Anyone can do that. You can pretend to be Chinese, use Jia 10 is not even a real last name. I don't know. Make stuff up, and do it after the New Year celebration of Chinese, New Year, or maybe it was just a coincidence. They weren't really meaning anything with that. But it can be anyone. Can you attribute to anyone? Not with the stuff that we have access to the public, right? We don't have access to any of the sensitive, important information. The ones that do have are potentially the Microsoft, which can check the GitHub logs, and Google, which can check the Gmail logs. And, it all comes down to a single packet. Seriously, it all comes down to one packet. 1 second you have the Gmail open, your VPN drops and reconnects, right? The Gmail page will detect the disruption and change in the network, reattempt to refresh the page, can make the WebSocket connections again, and your real IP goes up. Your VPN connects again. The connection state changes. The Chrome reconnects to the whatever socket, the Ajax, whatever the services Gmail is using. They all will reconnect, and your IP, real IP, will go to Google for a fraction of second. For a second, it will just go there. So if something like that happened, GitHub, Microsoft, Google, Gmail, they might know more, and they might be able to do a bit better and more educated, proper, evidence-based guess and attribution, if they ever do. I don't know. Lessons learned and key takeaways, right? So obviously, fix your bugs right away, right? If your backdoor code is not compatible with some variants and some targets, fix it quickly. See, they were late, they were slow, and some cutting-edge Linux build got the code as is, compiled and put it in there in the dev package and released, and then you eventually will be caught. Take your time, properly test it, and test it on as many as the variants of Linux as possible, or whatever software you're targeting and you're attacking. Then and only then put it in front of public, put it on GitHub, commit it to some repo, right? Do a proper testing, improve your testing methodology, and diversify your investment, right? When you're going after an XZ and maybe libarchive, okay, now you're caught, and it's gone. So it's diversify your investment. Don't go after just XZ and the libarchive. Do in more libraries. I'm joking. So all joking, okay? That was all joke. Bad taste, but it was all joke. So in reality, the lessons learned and last words are these. First of all, as you already know, I'm sure, no cutting edge builds in production or in sensitive environments. The cutting edge, why would you need that, right? In seriousness, like in a very sensitive environment, in production environment, sometimes catching your breath and slowing down and not going with the latest of every single commit and package and a fix and improvement, it's fine. Slow down, and sometimes take your time with the libraries, take your time with the packages and everything. Go with stable as much as you can. Maybe you have sensitive, some different type of project that requires a little bit more modern version, like Debian. Stable, maybe a little bit too slow, too old. But yeah, just find the middle ground. Just don't go cutting edge. That's all I'm saying. Validate the commits, right? Especially with a typo. Especially if they do not have much of a history with the project they are committing to, right? This dude, just look at it. I mean, again, it's banned and closed and filled. You can't see it now, but what you can see from archive and stuff. I mean, what was that check, man? That's just nothing. I can write that in a second. So that's not a real check. That's nothing. And then the other stuff that he was doing, the tests and improvement to the CRC that he was claiming, all that stuff. I mean, yeah, scrutinize more. Like with people who don't have history with the project and haven't done anything really, just take it with a grain of salt. Spend more time validating who they are, what they're doing. Also, don't ignore any wall grind messages. Usually, I know sometimes it's all false positive, but usually it's very correct and it's pointing to some problems, some issues. Take those seriously. And I don't know, I guess for open source projects of this size, that you see, if this was not caught now, right? Imagine, let's think that this was not caught in like 20-30 days, right? the XZ to the liblzma, and you can't imagine how many projects are using LZMA. Forget about the SSH. This backdoor was kind of targeting and hooking that RSA key validation and targeting the SSH. But if they wanted to go crazy, right, there are, I don't know, there's so many projects are using the liblzma, right? They could have infected a lot of other stuff, a lot of other projects. Open source projects, they're already doing, out of goodwill. No one is getting paid. This is all open source. People are doing it for free. It's already a hard job. Sometimes there's no reward, right? Nobody knows some people's names that you're using daily, their product, their library, their code in your day-to-day life, in your operating system. It's a tough job. So if possible, these big projects, maybe they should get some backing, if possible, from these big companies, and some more validation. It's not easy to do, but authenticate the people who make changes and commits that are sensitive to these sensitive projects, right? And also, in general, always patch ASAP. Hope you are not using any of these cutting-edge Linux OS and versions, but if you were using, please patch ASAP. So yeah, if you are cybersecurity and you were using Kali, and during, I think, March 23rd to March 26th or 7th, if you did an APT update and install our latest updates, you might have been infected. I don't think anyone uses Kali as daily driver, daily Linux. If you're doing it, please stop, get some help. You were using it as a virtual machine, or if you were using it live or whatever, you were using it temporary for a single pentest project, good. Delete that, build it. Now that it's fixed, and they removed the backdoor version from their repository, the APT repository. Anyway, yep, that's all I had to say very quickly. I know I keep saying quickly, and my videos keep getting longer and longer. I don't know how to fix that, but I'm gonna do my best. Anyway, thanks for watching. I just wanted to put this out there very quickly, and I will see you in the next video. Bye for now.